Hello, in this presentation we are discussing about the refrigeration system. The refrigeration is the process in which heat has to be removed from the source at a lower temperature and rejected to the atmosphere at a higher temperature. So basically refrigeration is the science of providing and maintaining the temperature below that of the surrounding atmosphere. Heat can spontaneously flow from higher temperature to lower temperature. So for heat to flow in the reverse direction, the second law of thermodynamics stipulates that external work should be supplied. Therefore, a refrigerator is a heat pump using power. The unit of refrigeration is called as ton of refrigeration, which is defined as the quantity of heat to be removed to produce 1 ton of ice at 0 degree centigrade within 24 hours when the initial condition of water is also at 0 degree centigrade. And in SI units, the value of 1 TR is equal to 3.5 kilowatt, and air conditioners are also specified by the same unit. Next is performance of a refrigerator. The performance of refrigerator is denoted by COP, that is coefficient of performance, which is the ratio of Q by W, where Q is amount of heat consuming, W amount of work. So these all are in same unit, Q and W, and COP must be always more than 1, as it is the reciprocal of the term efficiency. For example, in a heat engine, heat is converted into mechanical or electrical work. So during the conversion, some heat energy is lost, due to which the efficiency will be always less than 1. But in case of refrigerator, the input energy, that is W, helps only in transfer of heat. So COP is always more than 1, and higher the value of COP, performance of refrigerator can also be treated as higher or better. The next term is refrigerant. Refrigerant is the working fluid which is capable of absorbing heat at a lower temperature and rejecting the heat at higher temperature. Some desirable properties of refrigerant are this: it is having low specific heat, chemically stable, non-flammable, low cost, odorless, and no hazardous effect on leakage, easy to liquefy, boiling, low boiling point, low freezing point, etc. The type of refrigerants are mainly: first is Freon 12, Freon 22, ammonia, and other like carbon dioxide, sulfur dioxide, methyl chloride, CH3Cl, etc. These are mainly classified as primary and secondary refrigerant, and in most commonly used refrigerant is Freon 12, which is used in domestic refrigerator for refrigeration purpose. It has the boiling point of minus 29 degree centigrade. Now the air refrigeration cycle. Due to the availability of air free of cost from the atmosphere, air was used as a refrigerant even in commercial application. In this cycle, the 4 components which is used is compressor, cooler, expander, and refrigerator. The air is compressed in the compressor where the pressure and temperature are increased. The warm air from the compressor is cooled in a cooler with water. Then this cooled air from cooler expands in the expander, causing a big drop in pressure and temperature. And cold air from the expander is passed on the refrigerator, where it absorbed the heat and makes it cold. Then the air returned to the compressor and the cycle is repeated. So here the atmospheric air is used as refrigerant. The second one is vapor compression refrigeration method. In this cycle or in this system, the four main components which is used are: first is evaporator, second is compressor, third is condenser, and fourth is low pressure side expansion valve or expansion device. So the refrigeration effect is produced in the evaporator. The refrigerant enter in the evaporator as a wet vapor with low pressure and low temperature, and here it absorbs its latent heat of vaporization from the substance kept around the evaporator and thus cooling them. The refrigerant usually comes out of the evaporator with its phase change to dry, saturated or slightly superheated state, and then it enters the compressor, which is the heart of this system, and where it is compressed to a high pressure and high temperature. Then for this activity, power is supplied to the motor connected to the compressor, and it constitutes the major running cost of the system. The compressed refrigerant vapor is then enter into the condenser where it is condensed, and the refrigerant vapor condensed into high pressure fluid. The liquid refrigerant enter the expansion device, which can be a long spiral wound capillary tube, and here the refrigerant is throttled to low pressure, low temperature wet vapor, and thus the cycle is completed. The next one is domestic refrigeration system. It belongs to vapor compression type, and the evaporator, which is the coldest part, is located in the freezer compartment. A separate door is provided for the freezer where we can store ice creams and perishable items, and usually a chiller tray is also provided. Then there are several compartments with progressive higher temperatures. The condenser tubes are kept on the back of the refrigerator cabinet. The refrigerant vapor is condensed with the help of surrounding air, which rises above the natural convection, and the cold air is made to flow into the freezer compartment by a fan. So it is domestic refrigeration, which is used in our houses, and it is also known as Electrolux refrigeration system. It also has the same four components, like you can see in the figure: evaporator section, compressor, condenser, and capillary tube, which is act as expansion device. So it is very much similar with vapor compression. Now next is vapor absorption refrigeration cycle. In this, the three components are same like vapor compression, which is numbered as first evaporator, third condenser, and fourth expansion valve. But in place of compressor, here we are using an absorption system with the help of pump, absorber, and generator. So mainly low pressure vapor coming out of evaporator is compressed, but here in place of compressor, the compressor effect is produced by using an absorber, a pump, and a generator. The pump consumes comparatively lesser amount of electric power and a low cost fuel or any heat source including solar energy. Here the refrigerant used is ammonia and the absorber is water. So ammonia vapor coming out from the evaporator at low pressure is absorbed by water available in the absorber tank, and a strong ammonia solution is made in the chamber. The pump pumps the solution, thereby increasing its pressure, and high pressure solution into the generator. The generator, the solution is heated by external heat supply. So the weak ammonia solution is available in the generator, contains more amount of water, and it goes back to the absorber tank, where it absorbs the incoming ammonia vapor and becomes a strong solution once again. This process takes place in the condenser, expansion device, and evaporator are very much similar as we discussed in case of vapor compression. So the ammonia gas is condensed in the compressor, in the condenser, then it goes to the expansion valve where its pressure and temperature decreases, and it again converts to liquid phase, and then it goes to evaporator for the same purpose. So hence the cycle is complete. Next is the comparison between these two. Vapor compressor system is smaller in size, where absorption system is large in size. Refrigerant used in compression is Freon 12, where in absorption ammonia is used as a refrigerant. Electric power is needed to run the compression, where in case of absorption, heat input can be supplied by a heater or by exhaust steam or even by solar energy. So not electric power is essentially needed. Then COP of vapor compression is higher, where vapor absorption having lower COP. Wear and tear will be more and system produces noise in case of vapor compression, where in vapor absorption less wear and tear and the operation is silent in nature. The maintenance cost is high for vapor compression, whereas vapor absorption the maintenance cost is low. So this is all about the refrigeration system.